In this video, I am going to explain the structure and bonding of sulfur trioxide molecule. First, let us draw the skeleton. Center atom is sulfur and 3 oxygen atom connects to the sulfur atom. Both sulfur and oxygen have 6 electrons in their valence shell. We can write 6 into 4 equal 24. This means there are 24 electrons available for the bonding. Now I am going to complete the octet of outer oxygen atoms. Then I used 24 electrons and no electrons remain for the sulfur atom. It means that there are no lone pairs on sulfur atom. I am going to check whether the sulfur atom has completed the octet. It has 6 electrons. Now it needs another 2 electrons to complete the octet. But here thing we have to remember is sulfur can expand its octet, or in other words, sulfur can violate the octet too. Sulfur can keep 12 electrons in its valence. Now I am going to take electrons from all the 3 oxygen atoms. It results this structure. One of the double bond represents 4 electrons. There are 3 such double bonds. 4 into 3 means 12 electrons. If I check the number of valence shell electrons belong only to the sulfur atom, there are 6 electrons. That means this structure is correct. Next step, I am going to determine the formal charges. Before that, I am going to put the number 1, 2, 3. Then 1, 2, 3 sulfur atoms. Each atoms have 6 electrons in their valence shell. If I consider oxygen number 1, it has 6 electrons belong to its valence shell in this structure. All the oxygen atoms have identical bonding. So this one and this one also should have 6 electrons. And center sulfur atom has 6 electrons. This means there's no formal charge. All are neutral. This is the correct Lewis structure. Now we will move into the hybridization. When we consider the center sulfur atom, it has 3 bonding pairs and no lone pairs. That means it has 3 VAC pair repeats. The center sulfur atom requires 3 hybridized orbital to fulfill 3 VAC pair repeats. Now this is the electron configuration. We will consider only the valence shell electron because they are the one that participate in bonding. As mentioned earlier, the sulfur atom requires 3 VAC pair units to make 3 bonding pairs. We need 3 hybridized orbital. We can take 1 from S and 2 from P. But when we look in further, there are 2 paired electrons in 2 orbitals. Only 2 electrons unpaired in orbitals. That means this is not capable of creating hybridized orbital we need. Now we have to transfer 2 electrons into d orbital. I am going to transfer those two. 1 electron in S and 2 electron in P. Now this molecule also has 3 pi bonds. We can take 1 in P and 2 from D. So these create 5 bonds. These create sigma bond. So hybridization is sp2. Let us look at the oxidation number. These 3 oxygen atoms are identical. Then we can consider only 1 oxygen atom to determine the oxidation number. Oxygen is anyway more electronegative than sulfur atom. Thus the double bond means it withdraws 2 extra electrons. It gets extra 2 negative charge. Then sulfur atom get plus 2 charge from 1 bond. There are 3 such double bonds. Then the oxidation number of sulfur atom should be plus 6, because from each bond sulfur gets plus 2. From 3 bonds sulfur should get plus 6. Then I can write oxidation number of sulfur plus 6. Any oxygen atom out of 3 should be minus 2. Now I am going to describe the geometry. There are 3 VACPR units around the center sulfur atom. So the best arrangement is trigonal plan. This is the geometry of sulfur trioxide. You can see all the 3 oxygen atoms and sulfur atoms are in the same plane. You can see the trigonal plan structure. They can take into one plane like this. Let us look the electron cloud. This is how it looks like when we put the electron cloud onto the atom. If you want, we can remove this ball and stick model and we just go to this model. Then you can see inside this electron cloud trigonal planar structure.